Here's another example of a problem in the using the central limit theorem, just to help your understanding. Soft drink cans produced by a manufacturer are sold in cartons of 24. For all of the soft drink cans, the mean contents are 375 mils with a standard deviation of 3 mils. And two questions here. They seem very similar, but there's a subtle difference. If a soft drink can is chosen at random, in other words, just one can, what is the probability that it contains more than 376 mils? And the second part, if a carton of soft drink cans is chosen at random, what is the probability that the mean contents of cans in the sample is more than 376 mils? Very similar questions. Let's see how we deal with them. The first bit, let's think about it. All soft drink cans produced, the mean contents is 375. They're telling us that mu is 375 for the population. And the standard deviation for the population is 3 mils. Now, we're just choosing a soft drink can at random, and we want the probability that its contents are more than 376. So we're drawing a picture. Here's 375, the mean, 376, not far away in relation to the standard deviation, which would be here, 378 would be around this mark. So the probability contains more than 376. We've shaded the area to the right of 376. Now this is just a very basic normal distribution calculation, isn't it? We're going to use our graphics calculator and we're going to try and find this probability of a score greater than 376. Go to stats mode. We choose distribution. We're dealing with a normal distribution and it's NCD. We're dealing with a variable that's been chosen, that's fine. Now the lower value here is 376 and the upper value is the highest number we can put in our calculator. The standard deviation of the population is what we're talking about here, is 3. And the mean of the population is 375. So hit X here and we find the probability of one can having more than 376 mils in it is 0.369 to 3 significant figures. Probability of a soft drink can chosen at random contains more than 376 mils is 0.369. That's the first bit done. Now, what about this one? This time we're choosing a carton of soft drinks. In other words, every carton contains 24. So we're choosing a sample of 24 cans from the population, aren't we? Let's just refresh our memory. For the population, the mean is 375. The standard deviation is 3. Now for the samples, they're of size 24, so n equals 24. And we're interested in the mean contents. Well, the mean of the means of samples is the population mean. That's what the central limit theorem tells us, so it's 375. Now the spread of the means, or the standard deviation of the means of the samples, is given by the formula sigma on root n. So in this case, it's 3 over root 24, which turns out to be 0.61237. The standard deviation of the means of samples of size 24 is 0.61237. So now drawing our diagram, this is a normal distribution of the means of samples of 24. The mean of the means is 375 indicated. Now we've got to mark 376 much further across because the standard deviation is smaller, it's 0.61 for the spread of the means. Now we're trying to find the probability that a mean of a sample of 24 is greater than 376. It's the mean of the sample now greater than 376, not just one individual can. We're going to use our graphics calculator again. Let's go back and fill these things in correctly. Yes, it's variable. This time the lower is 376 is correct, upper is still the same, E99. But now, because we're dealing with this sample means, the standard deviation that we need to put in here now is 0.61237. The mean of the sample means is 375, so we leave it at that. Then we hit XE and we find now the probability that the sample means will be greater than 376 is fairly low. It's 0.051. And I've rounded off there to three significant figures, 0.0512. So there we have it. Two very similar questions dealt with in a different way, because one we're dealing with an individual can, and the second one we're dealing with the mean of a sample.